right now. Down a buffalo. Oh.
Think of that. So we're learning right triangle trig. So like in your homework, okay, they gave you, let's say, I don't want to use that triangle. I want to use this triangle here. This was like negative 8, comma 15. I think yours was a 17, wasn't it? Negative 8, 17, 15, 17.
Yeah.
Anybody have a problem like that? Notice where this guy's negative 8 and this guy's 15. How do we find this side? Good old Pythagoras, right? Yep. We say a squared, which is 4, plus b squared, which is 225, equals c squared, plus 289 equals c squared. So what is c? Square root of 2. C is square root of 289, which is 17, if you recall. Anybody have a question there? Right? And then I say find the 6 trig function. So I say to myself, okay, so I say, all right, sine of theta is, notice this would be where my theta is, even though this is your angle, that's the theta I would stand at, correct? Okay, makes sense. And I say, okay, sine is old hippie, so opposite over hypotenuse. I thought that was right. So secant then is 17 over 15, right? How many guys remember this? How to get it? Okay, and then I say, oh, I would like to erase this stuff and then put in cosine is some supposed to be a hippie, so that's negative 8 over 17, more lovely so-called poets, right? And that is secant of theta is negative 17 eighths. Am I boring you yet?
Cosecant versus sine.
Yeah, the cos don't go. Remember that thing? I think that's a good thing.
It's a good saying. It's just
Tangent of theta is on apples, so that would be opposite over hypotenuse or negative 15. So therefore cotangent of theta is negative 8 over 15. Did I talk to you guys about last time about how tangent of theta is sine over cosine? I did talk about that? Okay. So therefore cotangent is what? Cosine over sine. Okay? Anybody have a question there? Or anybody gonna die on that? We're okay with that? Okay. With that being said, okay, they're gonna ask you some of that, and then what they're gonna do is they have a little chart. So this is the trig function. This is the function. This is your degree. This is your radian. And then this is your tangent. What I mean by that, well, you guys catch up here too. Pretty much function. My clock is gone. Function, so with that being a function, that's kind of like saying, oh, we're going to go with cosine of 30 degrees. Okay, so what do you think they're meaning for the other parts here? Well, what's the radian measure of 30 degrees as well? Pi over 6, right? And then to me, I say, okay, pi over 6 is the coordinate root 3 over 2 comma negative just a half. And cosine is the x value, so my answer would be root 3 over 2. That's what you're feeling. They'll give you a... Huh? yeah, they can give you a radian, they can give you a degree. What else could they give you? A trait function, but it can be secant. And let's say it turns out to be 1.2. Okay, let me explain my thought process here. So to me, do you guys think in secants yet? No. So what is secant? So what is the equivalent? It's the same thing as 1 over cosine, right? We thinking 1's over cosine on the unit circle. No, we look at cosine. So I'm looking for cosine. So see how I flipped it? So what do I have to do to my answer? I have to flip it. So basically I'm asking where is cosine negative a half? You guys see what I'm looking there? Yes, no? So now I say to myself, where is cosine negative a half? Well, there's 2 spots for it, isn't there? It has to be in quadrant 2 and quadrant 3. X value is negative a half, so that means it has to be 60 degrees away from 180. So 1 or 2. This is equivalent to 2 pi there. And I know it has to be 60 degrees the other way, and that is equality, which is 4 pi. Notice I had to have 2 answers here because there was 2 places that secant was there. Unless they tell me I can only have my answers between 0 and 180, what would be my answer then? The 120 and the 2 pi difference, right? Does that make sense to everybody? They could restrict our answers by doing such. Did I tell you guys have a test next week on Thursday?
No, you didn't.
Sure, I will give you a +1 on your test. Huh? Love you, Caitlin. Came tomorrow, Friday. I'm already later in the week than I did.
What day did you get it? What day were you supposed to go?
I'm not here tomorrow, correct? My tomorrow here is I have a meeting. Some of your, a lot of your meetings.
Friday? When you want to go?
It's tomorrow. Tomorrow. You're thinking today or today as well. All right. Onward, upward. Here we go now. How would you write the sine of 5 degrees, or how would you figure this out? 5 degrees, 12 minutes, and 40 seconds.
Teacher, please allow the drill.
Well, Scallywags got out early. Because they gotta use like 4 gallons of hairspray to make sure none of those hairs get out of line.
Especially now Medusa dance, you gotta make sure the hat's right.
Okay, so once again you might be saying, what the heck is degrees, minutes, and seconds? Well, degrees, minutes, and seconds is a better way to go ahead and instead of like 5.892734 something like that, it's a more precise way to write. Instead of having it 5 point something degrees, what you do is break it down a little bit. Let me show you how you get it back in between the decimals. Okay? There is how many seconds in a minute? 60. So what I do, let me pull out the old rabbit. Okay? So I turn that sucker on. Notice there I would say, okay, 40 divided by 60 tells me I have 0.67 blah blah blah. This is 0.6, that's 2/3 of a darn minute. Is everybody there with me? So therefore I'm going to add it to my minutes. So therefore how many minutes do I have? Well, plus that answer. And that's how many minutes I have, correct? So now I'm at 5 degrees, 12.67 minutes. Correct? Everybody there with me? Well, I don't want to put it in as minutes either. I want to put it in as degrees. Well, how many minutes are in a degree? What do you guys think? 60. 5 divided by 60. And I add that to my 5 as well. So therefore, this 5 degrees, 12 minutes, 40 seconds is the same thing as 5.2111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111 still say, okay, 40 divided by 60 is that, plus my 12, isn't it? So what I would do is now go sine 5, angle, degree, answer, angle, next. So my friend Stevens noticed it should be 0.0908, right?
Right.
What is it?
There's no times in this meeting.
Anyway,
Well, it's because you didn't have the other one substitution too, so that would be that.
so that's why I used my answer. Okay, but anyway, that's what you would do as well. There's the degrees and minutes if you're ever asked to do it. Does that make sense to everybody how to go about that?
Yep.
Okay. And you see the apps button. I don't know if you have the apps button, maybe. Okay, and then hit the angle. So one more time, Nikki, okay? Because I saw you shake your head that you didn't. Okay, so first off, we want to convert this guy in seconds into minutes, right? So I divided it by 60, and that's in our calculator next to that. 12 plus is basically 2/3 to the negative 12 to the 2/3. Okay? Now I want to convert him into degrees, so I divide him in 60. Whatever that is, I can just do 2, 1, 1, 1, 1, 1 forever, right? So then how many degrees do I already have? So we only add 5 to that, and we just take the sum of the factors. Does that make sense to you? You okay with that? Yes, sir. Okay, so unit analysis, just like you did with radians and degrees. Remember doing that? How many in 1 minute for that? There is 1 minute. There is 3 seconds. So therefore, I have just in seconds, and he needs to go down here to 40 seconds. So if he goes down here, he's going to have 1 minute, and I'd have to convert that into how much that is in minutes. Does that make sense to you? wants to divide by root 2, because when I divide that by root 2, that's x, and that's what these two sides are, correct? Does that make sense what I'm saying by that? If I solve for x, then I'll know what those sides are. Okay, so as Alex said, I'm going to divide by root 2. We've already discussed why we can't have square roots in our denominator, correct? Rationalize it, so therefore we times by root 2 top and bottom using the 2 ground here. And we got 20 root 2. What's root 2 times root 2? Root 4, which is 10 and 2 cancel to be a 20 and 2 cancel to be 10 root 2. So that is what x is. So that's what the side length is. Pretty easy, huh? You just got to set it equal to the side length that we're given. What if I told you that this side length was 5? What's this side?
5.
What's this side? 5 root 2. It's not very hard, right? That's the nice one. Guess what one you probably usually always want to know? That one. Okay, now we're going to go with the 30, 60, 90 triangle. Okay. What side did I give you? X, x root 3, or 2x? I hear x's, and I hear 2x's, and I hear an x root 3. Anybody want to argue? Go ahead.
Because the hypotenuse is always the 2x.
The hypotenuse is always the 2x. Notice we are not given the hypotenuse, correct? So it is not 2x. Go ahead, Kate. The one opposite of 30 is the x. Notice I switched your triangle around, didn't I? Okay, so be careful with that. And understand those angles can flip-flop because it's the same triangle, right? Okay, so notice the side opposite of 30 is our x. This guy represents x root 3, doesn't it? Everybody understand that? So when I solve for x, then we know this side. If we know x, then we know what this side is because it's 2 times the x value, isn't it? Does everybody understand that? Okay. So when I do this, I'm going to go ahead and solve. So I have 4 over root 3 equals x. We need to rationalize our denominator. So what are we going to do? Times by what top and bottom? Root 3. So I have 4 root 3 over 3. Can that reduce? Like the other one did? So that's what this guy right here is. What's this guy? That is times by 2, so it's 8 root 3 over 3.
This is one thing I don't understand. Why would you times putting it under the square root divides it?
Okay, so when we multiply fractions, how do we multiply fractions? Okay, if I had 4 times 2, I don't times by 2 over 2, do I? Because that's 1, that's multiplying by 1. So if I want to go 4 times 2, we go straight across. 4 times 2 is 8, 1 times 1 is 1. So same thing here. If I have 4 root 3 over 3 times by 2 over 1, 4 root 3 times 2 is 8, and 3 times 1 is...
Yeah, but why did the 2 and the root 3 multiply?
Because, oh, okay. First off, you can't multiply a number underneath a square root unless you're in a square root. So like, first off, like, okay, 2 times root 3, what does that answer? 2 root 3. If I want to jump underneath him, I need to make him a square root as well. So that's like square root of 4 times square root of 3. Now I can multiply underneath. Right? And then if I break that down, that's 4 and 3, which is 2. So it's still the same thing. No, it's not going to change. So, but if the only way I can multiply underneath radicals is I'm a radical. Okay? So, goes to 2, doesn't go underneath him, because you just can multiply the guy out. You're just doubling what it already is. 4 root 3, we're just doubling that size. So now it's 8. Okay? Make sense? Okay, everybody good with that? Alright, anybody have a question on how I use my special triangle? What time we get out of here again? Huh? Oh, it's 20 from now. Damn, it's 12 there. Oh, that's good. Okay. Ooh, I gotta draw me a river. Hold on. my river. We are gonna build a bridge.
Find me a river. Can you draw a fish in there, please? Make it orange, like Nemo, or like goldfish.
How about a dirty brown trout?
No, you already used brown. If it's gonna be brown, it can be pepper.
Shush. Who says I was an artist?
No one.
There we go.
There you
Like
go.
an infinity sign. Just takes me math and I got it. So we'll do a bigger tail. Hey, you never know.
It's like the Mississippi, okay? It's like a shark. It's not
Yeah.
that small.
Anyway, there's your fish.
Thank you.
I need to build a bridge. Okay, so I can get over my river. So, exactly, because those are monster fish. You guys ever seen that show they put hands in the fish to get them out? Like the fish swallows their arm and yank them out when they do it? So we're going to build a bridge. So we're going to find this distance here, huh? And that's going to be 90 degrees, isn't it? Okay. Well, I don't know that, but I can measure a certain amount along the thing. Let's say we measured that to be 70 feet. So if that's 70 feet, I laid on the ground to find out that this measurement is 37 degrees. I would like us to tell us what is the distance across the river. I guess I could have did the killer squirrel, but I decided.
I like the killer squirrel with the harpoon.
Bow and arrow. It's got to protect us. Okay. Squirrels like nuts.
What kind?
Acorns. They're kind of somewhat of
Those
a
are
nut.
corn.
Anybody want to help me out how we're going to find the bridge length? What trig function am I going to use? Can I use sine or cosine? Why? Because I don't want to know this, right? I want to know this. So some old hippie that has to use a hypotenuse, I don't have my hypotenuse. Caught a hippie. Once again, hypotenuse. Opposite over adjacent tripping on apples, right? Okay. So tangent, I don't know. Tangent of 37 equals what? This is back from geometry, guys. H over 7. And what do? Times by the 70, correct? And H equals 70 tangent of 37. We go to the machine. Turn it on. What mode? Degree, I'm in degree mode. What's the first? Take a quick, and I say 70 tangent of how much again?
Oh, I know the distance.
And that river is 52.787. That's right, big fish. It's almost like a whale.
70 feet long.
Shut your mouth. That's not that fish would not fit in that triangle.
Might be bigger than a triangle, I know.
It's a blue whale. Anyway. Does everybody understand how you're going to use that to do
It's like-
so? Opposite over hypotenuse is tangent, right?
Right.
So that's the trig function I use. Because notice I did have the adjacent and I have the opposite is what I'm searching for. So that's why I use tangent. I just went ahead and times the bottom over to get the thing that I was looking for by itself. Okay, you also did that last year. You should have. If you didn't, sorry. Okay, here we go. Next one, double, double, wink, wink, hint, hint, check, check, blah, blah, blah. I suggest you pay attention on this one. I don't know why. Maybe I do. Here is the road out in the middle of nowhere. We'll call that Nevada. find such height of the mountain. Okay? Notice this is the height of such mountain. Height. We'll even put that in black so you can work. Here out and about, out in the middle of nowhere, we have a few cacti. It's closer than it appears.
It's closer than the mountain.
You get what I'm saying. That's a cacti.
It's kind of
I hope it's closer than it appears.
I'm not an artist, okay? I don't know the perspective. All I know is that's the number. I learned that in 7th grade.
I need y'all mountains in the background from the sun.
That's called perspective. Anyway, so you have your car. The black car with the hot window. Okay, and you, by chance, just have a protractor and a compass with you. And you're like, that thing right there is 5 degrees. Your measurement of elevation, as Kate said earlier, is 5 degrees. This is a good thinking problem, guys, and I'm going to show you how to think. Okay? You travel by, let's say, 6 miles. So right about here, you went in 6 miles. Okay? You measure again. Now the height of the mountain now is 15. Not the height, but the angle of elevation. And it should be, because notice when I get closer to this wall, I'm looking up a lot higher than what you are in the back, correct? To see the top. Does that make sense to everybody? The closer you are to it, the higher of angle of elevation. Correct? Okay, everybody with me there? I would like you to find the height of the mountain. That's all I'm giving you. How do I do that? Well, first off, this measurement from here to here is what? I'm going to call him X. I don't know how much farther away we are to that mountain. Nor would you if you were measuring from a far distance, right? Okay. All you know is that you traveled in 6 miles, so what is this distance from here to here? 6 plus X. Does everybody understand how that distance is 6 plus X? You take your X amount plus the 6 amount, so I'll pull this into this X plus. Okay? Everybody understand where that came in? Alright, so now I'm going to draw my 2 triangles, not as scale as this one is up here, but basically I have this one that's 5 degrees, with the height of the mountain is X plus 6, that's the distance away, correct? And the other guy, here's the height of the mountain, is 15 degrees. We can only do this if it was 19. Yeah, probably not this one. Because on this one, we have to use system of equations. Because how many variables do I have? I have 2. So how many equations do I have to have? 2. Because that's how system of equations work. Remember, if you have 2 equations, you have to have, if you have 2 unknowns, 2 equations, 3 unknowns, 3 equations, right? Okay. Can anybody tell me which trig function I'm going to use for this one and this one that's the same thing? N. So this guy right here is tangent of 15 equals hypotenuse over x. Right? Opposite over hypotenuse, right? How about this guy? Can anybody tell me the trig function of this guy? Tangent of 5 equals h over x plus 6. Do we have question marks? Okay? Okay. Notice, guys, both equations have an h and both equations have an x, so we need to use substitution. Would probably be a good way to go. What variable is the easiest one to solve for in either equation? The h on the right-hand side, the littler guy, right? What is h equal to? H is equal to x tangent of 15. You guys all know tangent of 15 is just a number. Now I'd prefer you not to plug it in because it's an irrational number, probably, most likely. A number that goes on forever. So I don't want you to use your calculator yet. Okay? We should always use our calculator at the end to simplify it. Okay. So notice, understand this h here's what it looks like as I'm command. If you guys had x plus 6 times 3 equals 2x. You distribute. That's a number, right? Just like 3 is a number. Distribute it. It looks different, but it's a number, right? Yes, ma'am. And this was x plus 6 all along. So he times it through, I get x tangent of 5 plus 6 tangent of 5 equals x tangent of 15. So notice you distributed this, you get 3x plus 18 equals 2x. What would you do in this problem? You'd get the x's all on the same side, wouldn't you? Right? So I'm going to get the x's on the same side as well with the other guy. Because isn't this the same thing? A number times x plus this is just like a big number. This is like the 18. 6 times the number is just a number. Equals x times the number, which is like 2x, right? Is everybody with me there? Okay. So I'm going to subtract, so I get 6 tangent of 5 equals x tangent of 15 minus x tangent of 5. You guys ever really know why this would become negative x if I pulled him out over here? If I did this, 2x minus 3x, what do those guys have in common? You pull out that x, there's 2 minus 3, and that's why then you can subtract that because that's negative 1x. You guys know that's the reason why you could add it like that? Because you were just taught to just do it. But do you understand why you can do it? That's why you can't add 2x minus 3x squared. Because you just pull out the x, that's 2 minus 3x, I can't combine them. Right? Just like down here, if I pulled out the x, can I combine those? 2 minus 3, yeah, I can. Does that make sense what I'm trying to say here? So if you follow this process, you can basically go through the other one as well. That's basically what I'm trying to do. Okay? Alright, so as we continue on, move it up obviously. Okay, I'm going to factor out this x. Now, do you guys know what the tangent of 15 minus the tangent of 5 is? No. That's not. It's just that. What is x equal? You know x equals 6 tangent of 5 over tangent of 15 minus tangent of 5. Go to the machine! Then we come over here and we turn it on. And then I go to mode. And I go down to what mode? Degree, because I was measuring in degrees, correct? And I say to myself, okay, here we go. I say, alright. Alright, so I say 6 tangent of 5 divided by, I want to divide by that whole stuff, so I'm going to put parentheses around it. So I'm dividing by that whole thing, right? I'm going to do tangent of 15. What was that first? Tangent of 15 minus tangent of 5. Close that parentheses. So I close the tangent and I'm closing the parentheses. It comes out to be 2.98. Wow, that's a tall mountain. Okay? Well, that's in miles, isn't it? Why is that in miles?
6 miles.
Because we talked about this x being in miles. Well, first off, I'm not even done yet. That's x is miles. So that's x equals, what did I say? 2.908. Okay, I just got rid of my calculator, so I don't want to redo it again. Okay, but is that what I was looking for, is x? What am I looking for? Height of the mountain, right? So am I even done? So now, what do we know for our equation? Well, the height of the mountain is x times the tangent of 15, I think, isn't it? Isn't that what it says? H equals x tangent of 15? So now hit second, or just hit answer. Just actually hit time. Just hit time. Tangent of 15. Did it say answer tangent of 15? Okay. Hit enter. What does that tell us? 0.77. Okay, so H is 0.779. Okay, 0.779 miles. Do we measure mountains in terms of miles? Mount Everest, is that in 4 miles? 4 miles high. Is that how we do it? No, we don't, right? It's actually, is it 36,000? It's 9,000. Anyway, you get the idea. So what are we going to have to do? We're going to have to convert this. How do we convert this? How many feet, so this is in miles, 0.779 miles. And in 1 mile, we have 5,280. Would you know? Do you know the yardage to miles comparison? Nine. Yeah, 10. How would you do that? Okay, tell me what your answer. Now you don't want to adjust the x. Put your answer times 5,280, right? Gives you. What's that? X equals 4,130. I'm not saying it's not. It's the thought process to get through that. The system equations weren't matrices when you're doing them by hand. Try the wrong thing.
Probably a whole page worth.
Your homework was already given to you, correct?